Next topic, Bayes theorem. Statement of Bayes theorem. Let a sample space S be partitioned into n mutually exclusive and exhaustive events. N mutually exclusive and exhaustive events, say E1, E2 and so on En, and capital A be any arbitrary event which is subset of union ei is equal to 1 to n. I can write that one, that is A is subset or equal to union ei I is equal to 1 to n. Then I can write P of ei given A is equal to P of ei into P of A given ei by P of A, where that P of A is called total probability and is given by P of ei into P of A given ei by summation I is equal to 1 to n P of ei into P of A given ei, where that P of A is equal to summation I is equal to 1 to n summation I 1 to n P of ei into P of A given ei is called total probability. So the statement of Bayes theorem. Let a sample space S be partitioned into n mutually exclusive and exhaustive events, say E1, E2 and so on En, and A be any arbitrary event which is subset of union ei. Then I can write P of ei given A is equal to P of ei into P of A given ei by P of A, where that P of A is equal to summation I is equal to 1 to n P of ei into P of A given ei, that is called total probability. Here sample space, let us say this is a sample space S partition into n mutually exclusive and exhaustive events. So this is event E1, E2, E3, E4, E5 and so on, we will get finally En. So all these are mutually exclusive and exhaustive. Why all these are mutually exclusive here? Mutually exclusive means take any two, there is no common part for any two events, E1, E2 disjoint, E1, E3 disjoint, similarly E2, E3 disjoint. So mutually exclusive nothing but disjoint events. So all E1, E2 and so on En are disjoint events. And exhaustive, why these are called exhaustive here? See here all together E1 union E2 union and so on union En, that will give total sample space S. Because of this reason I can say that E1, E2 and so on En are exhaustive. E1, E2 and so on En are exhaustive. And A be any arbitrary event which is subset of union ei. So A here, let us say this is a circle A. That is the event A which is subset of union ei. Then this is a statement of Bayes theorem. Now we will see how we can apply this Bayes theorem. While doing problems, we will get clear idea how to apply this Bayes theorem. Now we will do problems on Bayes theorem. Three machines produces 70%, 20% and 10% of the total output of a factory. The percentage of defective output of these machines are 4%, 3% and 2% respectively. An item is selected at random and found to be defective. Find the probability that it is from machine 3. An item is found to be defective. Find the probability that it is from machine 3. So here we have to apply Bayes theorem. How can you say that we can apply Bayes theorem here for this problem? See here, there are how many machines are there? 3 machines. So what I said, a formula in Bayes theorem, P of EI given A is equal to P of EI, P of A given EI by P of A, where P of A is summation I is equal to 1 to N P of EI into P of A given EI. So to apply this Bayes theorem formula, first of all we have to identify what are EIs in the given problem. What are EIs in the given problem and what is A in the given problem. If you identify these two things, then we can apply Bayes theorem. Here what are EIs? EIs nothing but here are machines here. There are 3 machines are there. So 3 machines means here let us say E1, E2, E3. E1 refers let us say first machine, E2 second machine, E3 third machine. So it is given that what is the P of E1 here? Machine 1 produces 70% of total output of a factory. So P of E1 means that P of E1 70%. Since that machine E1 produces 70% of total output of a factory. So 70% means 70 by 100. So similarly P of E2, machine 2 produces 20% of total output of a factory. So 20 by 100. P of E3, machine 3 produces 10% of total output of a factory. 10% means 10 by 100. Now what is A in the given problem? Okay, these are EIs. EIs means machines. Machine 1, machine 2, machine 3. What is A in the given problem? So here A is the corresponding attribute in the given problem. What is attribute here? Attribute nothing but getting defective item. Getting defective item is the attribute in the given problem. So A refers here getting defective item from any machine. It may be from machine 1 or machine 2 or machine 3. So getting defective item is the attribute, that is A here. Now, so what is a P of A given E1? What does it mean here? P of A given E1 from machine 1 getting defective item. So what is given here? Percentage defective output of these machines are 4%, 3%, 2%. So from machine 1 getting defective item is 4%. So 4 by 100. Similarly, P of A given E2 is given. What does it mean? P of A given E2 means first we have to talk about E2. It means from machine 2 getting defective item. From machine 2 getting defective item is 3%. 3% means 3 by 100. P of A given E3 nothing but from machine 3 giving defective item, or machine 3 giving defective item is 2%. 2% means 2 by 100. So what is the required thing? Find the probability that it is an item is found to be defective. Item is selected at random, found to be defective. Find the probability that it is from machine 3. So here an item is found to be defective. Means we write A in denominator. So that event is happening first here. Found to be defective. What is the probability that it is from machine 3? Machine 3 means you write here E3. So here E1, E2, E3, machine 1, machine 2, machine 3. So an item is found to be defective. What is the probability? It is from machine 3. Machine 3 means E3. So this is the required probability. So from Bayes theorem here I value 3 here. And P of E3 into P of A given E3 by summation I is equal to 1 to N. Our N value here, number of machines are 3. I is equal to 1 to 3. So put I value 1, will get P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus for I is equal to 3 we will get P of E3 into P of A given E3. So simplify this one, substitute and simplify. We get what is the P of E3? P of E3 is 10 by 100 into P of A given E3. A given E3 is 2 by 100 by P of E1 70 by 100 into P of A given E1 is 4 by 100 plus P of E2 is 20 by 100 into P of A given E2 3 by 100 plus P of E3 10 by 100 into 2 by 100. So here we will get 10 into 220 by 10000 10,000 by here 4 into 70 into 4 280. So we will get 280 plus 60 plus 20 by 10,000. So 10,000 will get cancelled. So we will get 20 by here 60 plus 20 80 80 plus 280 360. So we get 1 by 18. 1 by 18 is the answer for this question, 18th one. Now we can do this problem by shortcut method directly without applying this formula. No need to remember this formula even. No need to remember this formula by applying the shortcut method. See here there are three machines. Here the sample space, write down your sample. This is a sample space divided into three parts: E1, E2, E3. I said sample space S is that a statement of Bayes theorem. Sample space S is partition into n mutual exclusive and exhaustive events E1, E2 and so on En. Here are only three mutually exclusive and exhaustive events E1, E2, E3. This is a sample space. And A is any event which is subset of union Ei. So this is A here. A is any event which is subset of union Ei. Now what is the given here? P of E1 here 70 by 100 is the corresponding probability 70 by 100. P of E2 probability is 20 by 100. P of E3 probability is 10 by 100. Now what is the P of A given E1? This is A. This circle is A. P of A given E1 is 4 by 100. This is a common part of A and E1. This is a common part of A and E1. That is 4 by 100. This is a common part for A and E2. P of A given E2 3 by 100. This is 3 by 100. Next P of A given E3 2 by 100. So we require probability that it is from machine 3. So machine 3 for machine 3 what is the corresponding probability here? See, multiply these two. For machine 3 what is the corresponding probability here? P of we require E3 by A from machine 3. For machine 3 means here 10 by 100 into 2 by 100. That is the corresponding probability for A and E3 for machine 3 by total probability. Total probability means sum of all these values. See, there is 10 by 100 into 2 by 100 plus for E3. For E2 is 20 by 100 into 3 by 100 plus for E1 the corresponding probability is 70 by 100 into 4 by 100. I am taking corresponding probability for E3 on numerator. Taking corresponding probability for E3 on numerator by multiplying these two numbers. by total probability. Total probability means for E3 this is the corresponding probability multiplying these two, plus for E2 this is the corresponding probability multiplying these two fractions 3 by 100 and 20 by 100, plus for E1 the corresponding probability is 70 by 100 into 4 by 100. So simplifying this one we get corresponding probability, that is the required one. So the probability that it is from machine 3 an item is found to be defective, the probability that is from machine 3 is we get 1 by 18. There is the corresponding probability. So we can apply that formula or we can go for this shortcut method. Both will be the same answer. Now if we applying this here, next going for 19th question. 19th question, there are three bags, ABC, three bags. With A here, A contains 1 blue, 2 red, 3 green, whereas B contains 2 blue, 3 red, 1 green, C contains 3 blue, 1 red and 2 green. A bag is drawn at random and two balls are selected from it. They are found to be 1 blue and 1 red. Find the probability that the selected balls are from bag C. Selected balls are from bag C. This is also application of Bayes theorem. So here three bags are given A, B, C. Let us suppose that E1 refers bag A, E2 refers bag B, and E3 refers bag C. Bag C. Now, what is the probability of selecting here? See here P of E1 selecting bag A. Selecting bag A. See here there are totally three bags. Out of three bags, you have to select one bag. It can be done in 1 by 3 ways. Similarly, P of E2 selecting bag B is also 1 by 3, since there are totally 3 bags are there, selecting one bag from 3 bags. Next, P of E3 is also 1 by 3. Also 1 by 3. Now, what is the P of A given E1? What does it mean? P of A given E1 means from bag A getting one blue and one red. What is the probability that getting one blue and one red from bag A? From bag A. So from bag A means here, see that bag A here we require one blue and one red. How many blue are there here? One. So 1C1, 1 red. So 2 red are there. 2C1 by total number of balls are here 3 plus 2 plus 1. 6C2. 6C2. So you get total here 2 by 15. 6C2 value 15. Similarly, P of A given E2. P of A given E2. From bag B getting one blue and one red. So one blue means here 2C1 into one red, 3C1 by 6C2. So 6 by 15 will get. P of A given E3, nothing but from, first we will talk about bag, after that one blue and one red. From bag C getting one blue and one red. So 1 blue means 3C1, 1 red, 1C1 by 6C2. So 3 by 15. So what is the required probability? Find the probability that the selected balls are from bag C. Bag C means here again we have to P of E3 given A. What is A here? The attribute A is here getting one blue and one red, where A refers getting one blue and one red ball from selected bag. It may be any one. It may be bag A or bag B or bag C. Where A is the attribute getting one blue and one red ball from selected bag. So the required probability is find the probability that the selected balls are from bag C. Bag C means here corresponding from E3. So that is equal to P of E3 into P of A given E3 by using that Bayes theorem by P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. So substituting all these values here, P of E1 1 by 3, P of E2 1 by 3, P of E3 1 by 3, and the P of A given even 2 by 15, 6 by 15, 3 by 15, simplify this one. Finally it will give 3 by 11. 3 by 11, or you can do by using that shortcut method also. Next question, a group consists of equal number of men and women. Of this group, 20% of men and 50% of the women are unemployed. If a person is selected at random from this group, the probability of the selected person being employed is. So it is given that equal number of men and women of this group, 20% of men and 50% of women are unemployed. So what about corresponding employed here? Regarding the men, it is given that 20% of men are unemployed. What about employed men? You can write 80%. 80% employed men. So what about unemployed women given 50%? So what about employed women? Employed women 50 only. Employed women 50 only. Here there are two categories, men, women. So let E1 refers men group, E2 refers women group. E2 refers women group. What is the attribute here? The attribute is employment. Employment is the attribute. So if a person is selected at random from this group, the probability of the selected person being employed. Probability of the selected person being employed means that person may be here men or women from any group here, from men group or maybe from women group also. We don't know that one. So being employed from any group. Any group means that is a required total probability. P of A is equal to, let's see that total probability I said, but the denominator part of that base theorem I said P of EI by A, P of EI into P of A given EI by I said P of A, where P of A is called total probability and where that P of A is given by, where P of A is equal to summation I is equal to 1 to n P of EI into P of A given EI. That is called here total probability. Total probability. Why we are applying here total probability? Because we need a probability of selected person being employed. Being employed from, it may be from men group or women group. So that is a required probability. So P of E1 into P of A given E1, E1 P of E2 into P of A given E2. So here P of E1 refers, so selecting men. So it is given that group consists of equal number of men and women. So probability of selecting men and women will be same, means you will get 1 by 2 P of E1 because equal number of men and women are there, into what is P of A given E2, probability of here A given E, what is A refers here employment, E1 refers men group. So what about here E1? E1 means men. So from men, what about how many employed men are there? Employed men. So employed men means here 80%. So 80 by 100 plus P of E2 selecting women 1 by 2 into P of A given E2. So E2 refers here women. So from women group, what about employment? From women group, employment is 50%. So that is a 50 by 100. So we'll get here 80 plus 50, 130 by 200. Or can I 13 by 20 is the final answer. So the required probability, that is the probability of selected person being employed. is given by 13 by 20. So here to apply that part of Bayes theorem. So that is the denominator part, that is called total probability. We are applying the total probability value. We are not applying that Bayes theorem completely. This is a part of Bayes theorem that is called P of A. That part is called here total probability. So now see that 21st question, next question. The probability that a student knows correct answer to a multiple choice question is 2 by 3. If the student does not know the answer, then the student guesses the correct answer. The probability that guessed answer being correct is 1 by 4. Given that the student has answered the question correctly, the conditional probability that the student knows the correct answer. So it is also application of Bayes theorem. See, how can I apply Bayes theorem here? See, to apply Bayes theorem, I said we have to identify two things. First thing is EIs. What are EIs in the given problem? What are EIs in the given problem? And what is A in the given problem? So like previous problem. In previous problem, what are EIs here? Men and women. Men, women. What about A? A refers employment. Here, what are EIs and what about A in this problem, 21st problem? So here, see, student knows the correct answer to a multiple choice question is 2 by 3. If the student does not know the answer, then the student guesses the answer. The probability that guessed answer being correct is 1 by 4. Given that the student has answered the question correctly, the conditional probability that the student knows the correct answer is. So here I can divide into two categories here. First, even student the correct answer. That is one category. E1. E2. Student guesses the correct answer. Guesses the correct answer. E2 refers student guesses the correct answer. What is the attribute here? Attribute A is student answer the question correctly. Student answer the question correctly. That is the attribute here. See, student knows the correct answer or student guesses the correct answer. But what about final attribute here? Student answer the question correctly means answer the question correctly means it may be from guess or it may be student knows the correct answer. It may be from guess or it may be from student knows the correct answer. So what is given in the problem here? What is see first item given in the problem? P of E1 probability that student knows the correct answer. Student knows the correct answer is 2 by 3. The P of E2. P of E2 not given the problem. How to find P of E2 here? If student does not know the answer, then definitely student has to go for guess. So student does not know the answer means we have to go for a guess. So 1 minus 2 by 3 that is equal to 1 by 3. So student guesses the correct answer is 1 by 3. That is not given the problem. So I am finding that is 1 minus 2 by 3 that is equal to 1 by 3. Student guesses the correct answer P of E2. Now it is given that probability that guessed answer being correct is 1 by 4. So what is here? P of A given E1 value and P of A given E2 value. P of A given E1. E1 means where E1 refers student knows the correct answer. If student knows the correct answer, what is the student answer the question correctly? If student knows the correct answer, then what is the student answer the question correctly? That probability will be 1 because if student knows the correct answer, definitely student answer the question correctly. Now, what is the P of A given E2? E2 refers student guesses the correct answer. If student guesses the correct answer, what is the probability that student answer the question correctly? So it is given that probability that guessed answer being correct is 1 by 4. So if student guesses the correct answer, that guessed answer being correct is 1 by 4. That is given in the problem. This is not given in the problem 1. Why I am writing here this probability that is a sure event or certain event. If student knows the correct answer, then definitely student answer the question correctly. Sure event. So probability is always 1. Now what is the required thing here? The conditional probability that student knows the correct answer. Given that student answer the question correctly. See here, student answer the question correctly. Answer the question correctly means I will write A in denominator. So that is happening first. Student answer the question correctly. What is the conditional probability that student knows the correct answer? knows the correct answer means I will write even in numerator, because out of these two events, that denominator event is happening first. So we have to write first in that event which is happening first in denominator, after that remaining event in numerator. So P of E1 given A. So that is equal to P of E1 by applying that Bayes theorem, P of A given E1 by P of A. Means here I can write P of E1 into P of A given E1 plus P of E2 into P of A given E2. So simplifying all these things. So that will give the given that student answer the question correctly, the conditional probability that the student knows the correct answer. Student knows the correct answer. So P of E1 is 2 by 3 into P of A given E1 is 1 by P of E1 is 2 by 3, P of A given E1 is 1 plus P of E2. P of E2 is 1 by 3, P of A given E2 value is 1 by 4. So simplify this one, and finally it will give 8 by 9. So that is the required probability. Required probability is 8 by 9. Next topic, random variable. So first I will give definition of random variable. A real number associated with outcome of a random experiment. Outcome of a random experiment is called random variable. What I am saying, a real number associated with outcome of a random experiment is called random variable. For example, number of heads obtained in tossing 3 coins is a random variable which can take values 0, 1, 2, 3. Saying number of heads obtained in tossing 3 coins is a random variable which can take values 0, 1, 2, 3. See here, generally we will denote a random variable by symbol capital X. So here random variable taking value 0, 1, 2, 3. What does it mean 0, 1, 2, 3 here? 0 nothing but number, here X indicates number of heads. X indicates number of heads obtained in tossing 3 coins. So in tossing 3 coins, you may get all tails. All tails means 0 heads, or maybe you may get 1 head or 2 heads, at most 3 heads. You may get at most 3 heads. So here X is a random variable where X represents number of heads obtained in tossing 3 coins. So with the corresponding probability, see here, what is that corresponding probability here? So where, what is the sample space for 3 coins? We will get HHH, HTH, HHT, THH, TTH, THT, HTT and TTT. So probability of getting 0 heads. 0 heads means getting all tails. All tails, there is only one variable case, all tails. So we get 1 by total number of variable cases are 8. Getting exactly one head. What is what exactly one head? Here we will get exactly one head. So for all these 3 cases, we will get exactly one head. As a 3 by 8. Exactly 2 heads. Here 2 heads, 2 heads, 2 heads. Exactly 2 heads in 3 cases. So 3 by 8. 3 heads, all 3 heads. There is only one case. There is all 3 heads. There is a 1 by 8. So this is called here, this tabular value circle, probability distribution. Probability distribution of number of heads obtained in tossing 3 coins. That is called probability distribution of number of heads obtained in tossing 3 coins. Here that P of X, corresponding P of X is called probability mass function. So now I will define what about types here. Types of random variables. We have two types of random variables are there. Now we go for types. First one, discrete random variable. Discrete random variable. Next, continuous random variable. Continuous random variable. There are the two types of random variables, discrete and continuous. So now giving definition for discrete random variable. If a random variable taking countable number of values, random variable taking countable number of values is called discrete random variable. A random variable taking countable number of values is called discrete random variable. Whereas a random variable taking uncountable values, uncountable number of values, uncountable values, then that corresponding random variable is called continuous random variable. What I am saying, a random variable taking countable number of values is called discrete random variable, whereas a random variable taking uncountable values is called continuous random variable. For example, for discrete random variable, I will give this example. This is an example of discrete random variable. Here x indicates number of heads obtained in tossing 3 coins. Number of heads obtained in tossing 3 coins. Here x is taking how many values here? 0, 1, 2, 3. Countable values. So I can say that is the corresponding discrete random variable. That is example of discrete random variable. Or I can use general example. Number of students in a classroom. Number of students in a classroom. Countable. So that is a discrete random variable. Now, what about example for continuous random variable? If you take a continuous random variable, what I am saying here, random variable taking uncountable values. For example, number of real numbers between 1 to 2. Number of real numbers between 1 to 2. So can you count these real numbers between 1 to 2? No, we can't count. So number of real numbers between 1 to 2, that is example for a continuous random variable. So uncountable real numbers are there between 1 to 2. So this is an example of continuous random variable. Now I can say that probability function of a discrete random variable is called probability mass function. What I am saying, probability function of a discrete random variable is called probability mass function, whereas probability function of a continuous random variable is called probability density function. So in general, PMF is denoted by P of X symbol. PDF in general denoted by PDF by F of X. What I am saying, probability function of a discrete random variable is called probability mass function, whereas probability function of a continuous random variable is called probability density function. PMF generally denoted by P of X symbol, whereas the PDF generally denoted by the symbol F of X. Now I will give the properties of PMF and PDF. If you see the properties of PMF, first property, P of X value always greater than or equal to 0. P of X, or I can write P of X is equal to X, always greater than or equal to 0. Second one, summation P of X value is 1. That is called total probability value is 1. Summation P of X is 1. See here, already I have given this example, number of heads obtained in tossing 3 coins, that where X indicates discrete random variable. Here X takes 0, 1, 2, 3. 0, 1, 2, 3. So here I said whenever it is a discrete random variable, the corresponding function is called, here P of X is called a PMF, probability mass function. If X is a discrete random variable, corresponding probability function of discrete random variable is called probability mass function. So here I said summation p of x value 1, that is the property of probability mass function. So here I add all these things here, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, will get 8 by 8. So that is equal to 1. So condition satisfied, summation p of x is equal to 1. Similarly, to take a continuous random variable, the properties of continuous random variable, first property f of x greater than or equal to 0, the function greater than or equal to 0, f of x greater than or equal to 0. Next, second property, integral minus infinity to plus infinity f of x dx is equal to 1. It is called total probability here. Integral minus infinity plus infinity f of x dx is equal to 1. That is called total probability. So here, in case of discrete random variable, we are using a sigma symbol here, whereas in integration symbol, because sigma here, I said here discrete random variable means countable number of values. So for countable number of values, you can go for sigma, whereas uncountable number of values, whenever there are uncountable number of values, no, we have to use the integration symbol. Integral minus infinity plus infinity f of x dx value is equal to 1. So they are the properties of PMF as well as PDF. Next, how to find the mean, variance, standard deviation of a discrete random variable. For discrete random variable, to find mean or average, we can denote mean or average by symbol mu, that is equal to expected value of x. E of x means expected value of x, that is equal to summation x into p of x. Variance, we can denote variance by symbol sigma square, that is equal to expected e of x square minus e of x whole square, where e of x nothing but expected value of x. Here expected value of x square, that is equal to summation, we can evaluate e of x square value by applying this formula, summation x square into p of x minus mean square, because e of x value is mean. Now standard deviation is a positive square root of variance. So standard deviation cannot be negative. So take only positive square root of variance, that will give standard deviation. Similarly, for a continuous random variable, mean or average mu, that is expected value of x, e of x is equal to integral minus infinity plus infinity x into f of x dx. Variance, integral x square f of x dx minus mean square. Here also same, standard deviation is equals positive square root of variance. Now see this properties of expectation and variance. Properties of expectation and variance. Expectation of ax is equal to a into expectation of x, where a is any constant. Well, expectation of ax plus or minus b, where a and b are constants, is given by a into expected value of x plus or minus b. Since here expectation of any constant is again same thing, that's why you will get since expected value of b is equal to b only. Expectation of any constant is again the constant value. Third one, expectation of ax plus or minus by, where a and b are constants. A into expectation of x plus or minus b into expectation of y. So here expectation of xy is given by expectation of x into expectation of y by y given x, or expectation of y into expectation of x given y. So if x and y are independent, then expectation of xy is equal to, will get expectation of x into expectation of y. These are regarding expectation properties. Now variance properties. Variance of ax is equal to a square into variance of x, where a is constant. Variance of ax plus or minus b, a square variance of x, because the variance of any constant value is always 0. Variance of ax plus or minus by, a square variance of x plus, will get plus here, plus b square variance of y plus or minus 2ab into covariance of xy. Here COV of xy nothing but covariance of x comma y. So similarly, variance of ax plus or minus by is equal to a square variance of x plus b square variance of y, where x and y are independent. Whenever x and y are independent, that covariance value will get 0. If x and y are independent, covariance of, for this case, covariance of x comma y will become 0. So we'll get that equation will become like this. So here the third term will become 0. So we'll get a square variance of x plus b square variance of y. These are the properties of expectation and variance. Next we'll do problems on random variables. First question, an exam paper has 150 multiple choice questions of 1 mark each, with each question having 4 choices. Each incorrect answer fetches minus 0.25 marks. Suppose 1000 students choose all their answers randomly with uniform probability. The sum of total of the expected marks obtained by all the students is. So this is application of random variable. So how can you apply random variable here? So it is given that an exam paper has 150 multiple choice questions of 1 mark each, with each question having 4 choices. Each incorrect answer fetches minus 0.25 marks. Suppose 1000 students choose all their answers randomly with uniform probability. The sum of the total of the expected marks obtained by all the students. So here I have to choose a random variable like this here. X is a random variable here, taking values 1 minus 1 by 4. Minus 1 by 4. See what I'm saying. See here x is this probability distribution. Probability. I'm taking probability distribution of a single question. Single question. Probability distribution of a single question. See here, if that answer is correct for that given question, so we'll get 1 mark. Otherwise, if fetches minus 0.25 means minus 1 by 4. If answer is correct, student gets 1 mark. If answer is wrong, student loses 1 by 4th mark. 1 by 4th loses means we will take negative sign. So that indicates that student loses minus 1 by 4. So with corresponding probability, what is the probability here? Each question having how many here? Each question having 4 choices. So here 4 choices. So we'll get here 1 by 4. To get correct answer, probability is 1 by 4. To get wrong answer, 3 by 4. I am taking here 1 by 4, 3 by 4. All 1000 students choose all their answers randomly with uniform probability. Choosing all their answers randomly. Each question having 4 choices. So to get correct answer, the required probability is 1 by 4. To get wrong answer, required probability is 3 by 4. So this is called probability distribution of a single question. Probability distribution of a single question. Now, what about expected marks for single question? Here, expect E of x. I said formula, expected value of x, that is a mean, or which is also called average, given by summation x into p of x. Why applying this formula? Why I am applying this formula? Is a discrete random variable. X is a discrete random variable taking only countable values, 1 minus 1 by 4, only countable values. So that is a discrete random variable. So to find a mean or expected value of x, that is also called average, given by E of x is equal to summation x into p of x. So summation x into p of x means here x values, p of x value. So 1 into 1 by 4 plus minus 1 by 4 into 3 by 4. So simplify this one, we get 1 by 16. So that is a mean value for single question. Mean value or expected value for single question. Now, see here how many questions are there in that question paper. Totally question paper has 150 multiple choice questions. Now, mean value for 150 questions. For 150 questions. For 150 questions, we will get 1 by 16 into 150. Mean value, or get a mean marks. I can say that mean. This is a mean marks for single question. Now mean marks for 150 questions. 1 by 16 into 150. Now mean marks for 150 questions. Now mean marks for how many students are there? Totally 1000 students. Mean marks for 1000 students. 1000 students. That will give sum of total of expected marks. That will give sum of the total of expected marks obtained by all the students. Mean marks for 1000 students is equal to 1 by 16 into 150 into 1000. That will give sum of total of expected marks for all the students. So simplify this one, that will give 9375. So your mean marks for only single question. Your mean marks for 150 questions, the mean marks for 1000 students, that will give the sum of total of expected marks obtained by all the students. So the final answer is 9375. Will get 9375. This is the solution for this question. 9375. Okay. So from first I am framing this distribution tabular values. After that we will getting a probability distribution of a single question distribution. Mean marks for single question, mean marks for 150 questions, mean marks for 1000 questions, 1000 students. Now come to that second question. A machine produces 0, 1, 2 defective pieces in a day with associated probability of 1 by 6, 2 by 3 and 1 by 6 respectively. The mean and variance of the number of defective pieces produced by the machine in a day respectively are. So here machine produces 0, 1 or 2 defective pieces. So here that is corresponding random variable is a discrete random variable because it is taking only countable values 0, 1, 2 countable values. So x taking values 0, 1, 2 with corresponding probability, given corresponding probability 1 by 6, 2 by 3, 1 by 6, 2 by 3, 1 by 6. But find out mean value. So mean given mean formula, mean or expected value of x, average is given by summation x into p of x. So summation x into p of x will get 0 into 1 by 6 plus 1 into 2 by 3 plus 2 into 1 by 6. Simplifying this one, that will give mean value 1. Next we need to find variance also. Variance, the sigma square is given by e of x square minus e of x whole square. So that is e of x means where mean. So to find this one, first I will find e of x square. What is e of x square? E of x square is summation x square into p of x. Summation x square into p of x. So that is equal to x square means 0 square into 1 by 6 plus here 1 square into 2 by 3 plus 2 square into 1 by 6. So that will give e of x square value. Simplify this one, we will get 2 by 3 plus here 4 by 6. 4 by 6 means again we will get here 2 by 3. 2 by 3 plus 2 by 3, 4 by 3. 4 by 3. Now, so required variance is given by e of x square minus e of x whole square. So we got e of x means that is the mean value. We got mean value as 1. So 4 by 3 minus 1 square. So 4 by 3 minus 1 square is 4 by 3 minus 1. So 4 by 3 minus 1 is 1 by 3. So we get variance value 1 by 3. Mean value 1. So that is option A is correct. So mean value 1, whereas variance value 1 by 3. Now we'll come to this third question. Third question, find the value of lambda such that the function f of x is a valid probability density function. PDF nothing but probability density function. So we have to find out lambda value, unknown value. So to find that value, we have to apply the properties of PDF. I said that second property of PDF, integral minus infinity plus infinity f of x dx value is 1. That is a total probability value 1. Integral minus infinity plus infinity f of x dx is equal to 1, where f of x is a PDF. If it is a PDF, definitely it must satisfy this condition. It must satisfy this condition. So here f of x value is given 0 otherwise. So it is given only f of x value function is given lambda into x minus 1 into 2 minus x for only between 1 to 2. In other intervals, it is 0. So I can write it implies integral 1 to 2 lambda into x minus 1 into 2 minus x dx is equal to 1. Applying that property of PDF. So now lambda into, so multiply here 1 to 2, so we'll get 2x, here we'll get 2x minus x square minus 2 plus x dx is equal to 1. So now integrate term by term and apply the limits, solve for lambda, finally it will give lambda is equal to 6. Integrate term by term and apply limit here, upper limit minus lower limit, solve for lambda, that will give lambda is equal to 6. So this is the answer for the third question. Now come to that fourth question. The variance of the random variable x with the PDF. PDF is given, let find out corresponding variance of random variable. So here whenever PDF is given, that is a corresponding random variable is a discrete, no, that is a continuous random variable. Whenever PDF is given, the corresponding random variable is a continuous random variable. So how to find the variance of continuous random variable? So to find variance, first we require mean here. There is a mean or average or expectation of x of a continuous random variable integral minus infinity plus infinity x into f of x dx. So here, so I can write this one as integral minus infinity to 0 x into, so I can write minus infinity plus infinity x into f of x. What is f of x here? 1 by 2 into mod x into e power minus mod x dx. So I am replacing that x, f of x value, f of x with 1 by 2 into mod x into e power minus mod x. Now which is of the form integral minus a to a f of x dx. So we know that one formula integral minus a to a f of x dx is equal to twice 0 to a f of x dx. If f of x is even function, the same thing is 0 if f of x is odd function. What I am saying, integral minus a to plus a f of x dx is equal to twice 0 to a f of x dx if f of x is even function. The same integral value is 0 if f of x is odd function. What is even function, odd function? If f of minus x is equal to f of x, then f of x is said to be even function. If f of minus x is equal to minus f of x, then the function f of x is said to be odd function. Now check this one, is it even function or odd function? Let's check this function. This is our f of x. Replace x with minus x, f of minus x. If f of minus x, what is f of minus x here? Replacing x with minus x 1 by 2 into replacing mod x with the minus mod x e power minus mod x. So modulus of minus x is again plus x only. So we get minus x into 1 by 2 modulus of minus x is mod x only, e power minus mod x. So we got that is equal to minus f of x. This is again f of x. So f of minus x is equal to minus f of x. Therefore that function f of x is said to be odd function. So whenever that is odd function, value of that integration is 0 according to this formula. So e of x value is 0 since that is a odd function. Now finding, what about how to find that variance value? See here, to find variance, we have formula in continuous random variable. Variance is given by e of x square minus e of x whole square, that is equal to integral minus infinity plus infinity x square into f of x dx minus mean whole square. Integral minus infinity plus infinity x square into f of x minus mean square. We got mean value 0. So first we have to evaluate this value. What about integration of this function? Integral minus infinity plus infinity x square into f of x. What is f of x here? 1 by 2 into mod x e power minus mod x dx. So evaluating this integral. So what about this function? See here. Here again check that condition. F of minus x, or replace x with minus x, we'll get again f of x. So that is an even function. F of minus x is equal to, we'll get f of x. Therefore that is the even function. So I can apply this one as twice 0 to infinity, uh, twice 0 to infinity x square into 1 by 2 into, so between 0 to infinity mod x value x only, e power minus x dx. Between 0 to infinity mod x value is x. So here 2 will get cancelled, we will get integral 0 to infinity x cube e power minus x dx. X cube e power minus x dx. So value of this integration is 3 factorial, that is equal to 6. That is equal to 6. You can go for that integration by parts, integral uv formula, integration by parts. Or I can do one shortcut method here, integral 0 to infinity x power n into e power minus x dx is equal to n factorial. Integral 0 to infinity x power n into e power minus x dx is equal to n factorial. According to that shortcut formula, I can say that value of this integration is 3 factorial, that is equal to 6. That is e of x square value. Now see here, substitute here, e of x square value 6, mean value 0, so that is equal to 0 square. So we'll get 6. So finally we got variance value 6. So for this question, answer is 6. If a coin is tossed repeatedly till both head and tail appear at least once, the average number of tosses required is. So coin is tossed repeatedly till both head and tail appear at least once. Let us consider, let x be a random variable which denotes number of tosses required, to get first head. What I'm saying, let x be a random variable which denotes number of tosses required to get first head. Now see here, p of x is equal to 2. I can write, say, first you may get tail. Whenever you get first head, then you have to stop the experiment. So first you may get tail, next head. This is one possibility. P of x is equal to 3. Tail, head. Whenever you get head at the end, you have to stop that experiment. For P of x is equal to 3. Similarly, P of x is equal to 4. H, and so on, like that will get. Where x denotes number of tosses required to get first head. So TH means probability of getting tail 1 by 2, probability of getting head also 1 by 2. Again write 1 by 2 whole square. TTH, probability of getting tail, head. So probability of getting head or tail both have equal probability 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2 will get 1 by 2 whole cube. Here also will get 1 by 2 whole power 4 and so on. Now see here x is a random variable taking 2, 3, 4 and so on. And corresponding p of x value is 1 by 2 whole square plus that is 1 by 2 whole cube, 1 by 2 whole power 4 and so on. So here x is a discrete random variable. So here it is taking countable values 2, 3 and so on till infinite. So even though 2, 3 and so on till infinite, all these are countable values. We can count all these values with corresponding probability 1 by 2 whole square, 1 by 2 whole cube, 1 by 2 whole power 4 and so on. Now see here average value, we require average number of tosses, means take average value or mean, that is expected value of x. Average value or mean, that is expected value of x, is given by formula summation x into p of x. So summation x into p of x means 2 into 1 by 2 whole square plus 3 into 1 by 2 whole cube plus 4 into 1 by 2 whole power 4 plus and so on. So that is average value or mean value or expected value. Now taking 1 by 2 common, we will get 2 into 1 by 2 plus 3 into 1 by 2 whole square plus 4 into 1 by 2 whole cube plus and so on. What about sum of that infinite series? 2 into 1 by 2 plus 3 into 1 by 2 whole square, 4 into 1 by 2 whole cube and so on. So here I will do one thing, 1 by 2 into add 1, subtract 1. 2 into 1 by 2, 3 into 1 by 2 whole square plus 4 into 1 by 2 whole cube plus and so on minus 1. Adding and subtracting 1. Why? Because we have a standard expansion. This is a 1 plus 2x plus 3x square plus 4x cube plus and so on, that is equal to, I can give this expansion as a 1 minus x whole power minus 2. We have this standard expansion 1 plus 2x plus 3x square plus 4x cube and so on, that is a 1 minus x whole power minus 2. So to apply this formula, we have to add and subtract 1. So that is equal to 1 by 2 into here 1 minus x, x is here 1 by 2 whole power minus 2 minus 1. So simplify this one, finally it gives 3 by 2. Simplify this one, finally it gives 3 by 2. Similarly, this is what I am taking here, x is a random variable which denotes number of tosses required to get first head. Similarly, I will take let y be the random variable which denotes number of tosses required to get first tail. What I am saying, let y be the random variable which denotes the number of tosses required to get first tail. For that one also we will get again same thing. Find that expected value of y. We get same values here. Expected value of y, that will give again 3 by 2. So now expectation of x plus y, we require average value. So expectation of x plus expectation of y. So that is equal to 3 by 2 plus 3 by 2. So 6 by 2, that is equal to 3. What I am saying, like this also, what I am taking here, y is a random variable which denotes number of tosses required to get first tail. First tail. Again we will get the same thing, p of y is equal to, first tail means we will get here ht. P of y is equal to 3, hht. P of y is equal to 4, hht. So we will get same sequence, we get same series, we will get final answer same 3 by 2. So the expected value of y is 3 by 2. Expectation of x plus y, expectation of x plus expectation of y, using properties of expectation. So 3 by 2 plus 3 by 2 will get final answer 3. So this is the answer for this question. Now see that sixth question. Consider a dice with the property that the probability of a face with n dots, showing up is proportional to n. The probability of the face with 3 dots showing up is, consider a dice with the property that the probability of a face with n dots showing up is proportional to n. Proportional to n, the probability of the face with the 3 dots showing up means here x is a random variable. Here dice means it contains number 1, 2, 3, 4, 5, 6, corresponding p of x. Proportional, here a proportional value means let us say that proportionality constant be k, we will get k, 2k, 3k, 4k, 5k, 6k. Here k is any constant. So proportional to n means here k, 2k, 3k, 4k, 5k, 6k. So since it is a discrete random variable, it must satisfy the condition that summation p of x is equal to 1. So this is the property of discrete random variable. Summation p of x is equal to 1. So it implies k plus 2k plus 3k plus 4k plus 5k plus 6k must be 1. Must be 1. Now, so find that k value, will get k is equal to 1 by 21. So simplify that one, we will get k is equal to 1 by 21. That is the k value. But we require what is the probability of phase showing, the probability of the phase with 3 dots showing up. 3 dots showing up means these are 3 dots showing up. The corresponding probability value is 3k. 3k. So 3 into 1 by 21. So we will get 1 by 7. Probability of phase with 3 dots showing up is 3k. Here 3 into 1 by 21 will get 1 by 7. So 1 by 7 is the answer for this question.